Our last tour of the two-dimensional objects takes us to circles. A couple key pieces that we need here. There's lots of things we could talk about in terms of circles, but here are the ones we're going to focus on. So if this is the center of the circle, usually just marked with a dot, sometimes labeled as O, the radius is anywhere from the edge of that circle to the center. So the radius is going to be something like that. Of course, if I take the radius and I extend it 180 degrees in the opposite direction, that's also a radius. So anywhere from the outside, the perimeter, the circumference of the circle to the center. And in case, if I have 2 times r, that's the diameter of the circle. The diameter absolutely has to go through the center. Absolutely possible to have lines that don't go through the center. That, for example, would be a chord. Or if it extended beyond the circle, we would call it a secant. But the key pieces that we're interested in are the radius, or if we have 2 times the radius, the diameter. So the diameter is equal to 2r. A tangent, that's an interesting one, is a line that touches the edge of the circle at just one point. So what I drew previously was a secant. It crossed the edge of the circle twice. A tangent crosses only once. Touches only once, rather. And what's interesting about a tangent is if I take the point where the tangent touches the circle and I draw a straight line to the center, in other words, the radius, we find that the tangent and the radius are at 90 degrees from each other. All right, and finally, the circumference of the circle, the perimeter, has a start formula of 2 pi r. And the area is pi r squared. Remember that pi is approximately 3.14, but unless stated otherwise in a MyLab question, if you're using pi in your calculator, I encourage you to use the pi symbol. That gives you as many decimal places as you could possibly need. So look for the pi symbol on your calculator rather than approximating it to 3.14 or other approximations. Let's look at some problems. All right, in this case, we're told this is a machine part, but in any case, it's a square, so that's why side is labeled as S, and we could also show this using notches. This would show us that all 4 sides have exactly the same length. And what's been removed here is a quarter circle. So we know that if we continue this all the way around, that the white part shown here would be 1/4 of that circle. Okay, and we're asked to find the perimeter and the area of the shaded part, so the part in here. Let's start once again with the perimeter. What do we know? All right, so if this is 1/4 of a circle, then we know that what we're looking at here, this side length and this side length, is the radius. And we know that length. We know that the radius of the circle is also the side of the square and has a value of 3.25 centimeters. The reason we need to know the radius is we'd like to know what distance this is. This is going to be 1/4 of the circumference of the circle. So the perimeter is composed of 1/4 of the circumference of the circle plus these 2 sides on the left and on the right of the square. So 1/4 the circumference of the circle. The circumference of the circle is, of course, 2 pi r. So 2 times pi times r, we'll fit that in there, and then we'll do a little bit of algebra. And then 2 times s. So I've just, once again, written down the entire formula. So it's time to fill in some of the pieces. I can simplify this already using what I know about multiplying fractions. 1/4 times 2 pi r becomes 2 pi r over 4. So I can simplify this. 2 over 4 simplifies to 1 over 2. Right? So I can simplify, I can cancel 2 divided by 2 is 1, 4 divided by 2 is 2. That's the other way to show that. I can simplify this to pi times r divided by 2 plus 2s. You don't need to do that. You can just start filling in the variables here. You can fill in the value for r and the value for s, but this tidies it up and will make our calculation a little bit faster. So we've got pi times r. R is same value as s, 3.25 centimeters. We just labeled it as r to make it easy to understand that we were talking about the radius. And so 2 times s gives us 2 times 3.25. Throw all of that into your calculator and you get 11.6 centimeters. All right, let's take a look at the area. So what's happened is we have the area of the entire square. So for the total area, we have the area of the square. I'll call that a subscript s. And what we're subtracting out is 1/4 the area of the circle. So I'll call that a subscript c. So the area of the square would be s squared. And the area of the circle is pi r squared, and we want 1/4 of it. Let's start filling that in. So s squared, that would be 3.25 squared, and then we'll subtract 1/4 times pi, and then times 3.25, that's the value of r squared. Putting that into my calculator gives me 2.27 centimeters squared. And again, in both of these cases, when I'm calculating the perimeter, when I'm calculating the area, I'm using the pi button on my calculator rather than approximating to 3.14. We'll actually look at this question again when we look at three-dimensional objects, but right now we're just going to look at the surface, the very top portion of this pumpkin pie. So we're asked specifically for the surface area of the top of the following pie. It's got some crazy dimensions, bear with me. It's got a radius, this guy here, of 20 centimeters. And what's been cut out of it is one of these pieces, and the angle in here is 35 degrees. So we're also told that the pie has a height of 2 centimeters, but for this particular question, we're only interested in the top surface area, so this piece in here. So one nice way to calculate a portion of a circle is to work with ratios. So we can think about how much is missing, but we can also, of course, think about how much is left. What is the angle left here? If I take 360 degrees and I've removed 35 degrees, we're left with 325 degrees of the original 360. So you can think of it this way. If you take your pie and cut it into 360 pieces, you still have 325 of those 360 pieces left over. It's a lot of pieces for a pie, but it works here. In other words, we have 325 of the original 360 pieces remaining. So we have 325 3/60ths of the area of this circle. And what is the area of the circle? Okay, so the area of the surface is going to be 325 3/60ths of the area of the circle. So we have 325 3/60ths of pi r squared. So now we just have to fill in the value for r of this ludicrously large pie. So we have 325 over 360 times pi times 20 squared, which gives us 11.34 centimeters squared.